Your job is to start tallying fruit flies. So you're going to tally how many, take note if the fly has red or white eyes, and then take note if it's a male or female. If you have a male with white eyes, you tally it.
The Fruit Fly project is meant to accompany a genetics unit. And so my students have been learning about how traits are passed from parents to offspring to the next generation on. And the fruit flies is a really good way to allow students to see multiple generations of actual living organisms as they pass their traits from one parent generation to the corresponding F1 and F2 generations. This program has allowed me to be mindful of making sure that I am including lots of good practice in my teaching, because it's important for students to see the connections between science and math, and for teachers to use technology to help the students with that, to help them just see real science happening in the classroom and real science happening around them in their life, and that's bonus.
Those two different groups of posters are the ones we're going to use. Today you'll get a copy of that so you can see it up close.
Punnett squares are really nice ways for them to start predicting what the offspring should look like, and what we're doing with our students right now is having them work through the first Punnett square for their parent generation, and we know what the genotypes and phenotypes of those parent flies are, and so we should be able to predict what our offspring would look like. We've collected our first generation data, and we're noticing that our data doesn't necessarily match perfectly with what we predicted. So students get the chance to see how scientists may or may not make little bits of error. They can see error that they've made and then think critically about why they saw that error.
I've done it in math class, but not like with something that's real. It's just like a made-up situation. It's just weird to look at, because you see all these tallies, but you don't really understand it until you like look at it completely with a graph and everything. So it's just kind of cool to put it into perspective.
Seeing that the math is a language for science, inquiry, and allowing them to see how it's all actually really connected, and it's not these isolated incidences that they experience throughout their day, that they actually, we're going to use that all to accomplish the answers to that inquiry.
I think that an integrated approach is important because, again, it allows the students to have that real life experience. It allows them to make connections between math and science and technology, and it's allowing them to see that happen right in front of them, and it's